So with that being said, now let's talk about memory, right? So here's just a quick overview of how things that we need to know when it comes to memory analysis. Couple of different tools that are available, but basically, why are we looking into memory? Memory has a bunch of information that you would not be seeing otherwise in any other place. That's because memory contains the volatile data that we can use in order to find out, certain activities that might have been happening at that time on the system, such as processes that were active, network connections that were active, codes that might be still injected into certain processes. We just get the full state of in-memory data. And that's really helpful information that's not really logged anywhere else. If you shut down a system, memory is gone, and we won't be able to look into these kind of, get that kind of valuable information anymore, unless it's, captured by EDR systems, things along those lines. But if you look into memory, this is what we are looking for and why it's important. And for that, we typically create a memory dump. Memory dump is basically a binary file with the exact state of the RAM of the system at the specific point in time when we took the image. So that's typically a 2 GB or 4 GB or 16 gigabytes, file that is, basically representing the RAM of the system that we are interested in. So there's a few techniques of how we can actually go about that. We won't be covering that today. We covered data collection previously. But one thing that's important to know is memory can be limited, right? So sometimes systems run out of memory, and Windows has a simple way of dealing with that. It just basically pages out certain areas of the memory to the disk, because that's where we have more storage available. In certain areas that might not be used at the point in time by the system might be paged out, and that is being done and stored into a page file.sys. So this is why there's a number of files on Windows systems, and this is one of the interesting ones that are also related to memory analysis, because there might be data in a page file that is maybe not available within the memory image itself, because data might have been paged out. So don't forget about that file. We'll have it today as well. That's why actually I'm bringing it up too. And in terms of tools, there's a few ways how we can look into memory. What we're going to be looking at today, just very straightforward and simple. I think most of people or everybody might be familiar with volatility. So volatility is basically the #1 tool out there that is going to be able to parse the objects from a memory and then show that to us. So we can actually parse out for processes, network connections, files, dumping files, even extracting them from the memory, command lines, things like that. We'll see that later, but this is really the most common industry standard tool that's out there. Now, there's a few more, especially lately coming up, where you can actually achieve similar things, like memprocfs, I think it's called, can show similar information in different ways. Not something we cover today, but just saying more tools becoming available these days. And then, simply what we can do is we can just run parsers across the memory and see what sticks in terms of what's readable to us. And that can be done by just simple utilities such as strings to get the printable character sequences from unstructured data. So basically just characters and strings that we can read that might still be stored in a memory that can give away information, as well as tools that can do that on steroids, which is basically a favorite one of mine is bulk extractor. Similar idea. It just scans for patterns and puts them into different types of files depending on where this pattern matches to, what this pattern matches. So quick introduction to memory forensics before we now are jumping straight into it. I have my cheat sheet available here on the site. I actually have a few commands written up too, because there'll be dozens today, and I can't obviously remember all of those. But I have a forensic system ready to go, and I have already pre-processed this case. I have the memory dump file on my terminal, and I also have the page file.sys. Now, this is the memory dump that we have from our case files, right? This is the scenario that we've been handing out. This is the exact same memory dump. So if we're using volatility, for example, which is installed here, all we need to do is memdump. We need to point volatility to this memory dump, and then we have a bunch of options. Actually, let me show the options first. volatility is really cool. We can just say, take this file, this memory dump, and show me particular information. And all the information that's available here is listed. So basically those plugins that come with it, volatility 3, by the way. So for Mac, we have certain ways how to parse them. For Linux, we have ways to parse them. And for Windows, we have parsers for certain features, for certain artifacts. And so you can see Windows modules, Windows network information, Windows process information, Windows information from the registry, sessions, users, and then going deeper even into the VAD and tree and things along those lines. We can even do Yara scans, so more advanced things which are not needed today, but just saying all these plugins are available to us. And the most straightforward way of how we could run this is, first we need information about what we're looking at, right? In a real case, mostly you get data provided to you, but you do not know exactly if this is actually the system that you're thinking you've been provided with. So first we need to get information about the system that we're looking at. So if we just run Windows and then .info, that is going to parse the current memory image and tells us just some metadata, some information about the system itself that we are looking at here. So I'm not going into how volatility does this, but basically it knows how to parse the memory image. That is great. Corrupt memory image might give us a harder time, but we can see here there is the major and minor version of this particular system. We can see system root, product type, NT product server. So this is a Windows server system. And if you want to see which one exactly, then we can actually look up this particular major minor version, and then we'll see this is 2019. So this is one of the good news. It actually works, right? We are able to parse the memory image. It is not corrupt, which is awesome. So there's a few more things that we can do now, right? We want to see, first of all, just plain simple, show me the processes that are running, because there might already be something sticking out, right? And then we might, if there's any advanced techniques, might need to dive deeper into the processes, or if there's any other things that might be interesting to us, we can look for those, such as network connections, commands, things along those lines. So I have a quick cheat sheet here, and because parsing might actually take a while, I have ran those commands such as Windows PS3, and then just pipe them into text files like ps3.txt, and that allows me to store the output into text files. And so I don't have to run the tool over and over and over again, and I can actually grab and search through the files. And this is what you see here. We have the memory dump and then a bunch of text files, because this is the output of volatility. We have run the different plugins, such as command line plugin, file scan plugins to look for files, netscan, pslist, and so on, strings, and so on. So this is basically the output of volatility plugins that I've already ran. There's also timeline. So basically it puts everything that is associated, all the information that's associated in volatility with a timestamp, puts that into a timeline, and then sorts it by date. We do that in our practical Windows forensics course. People might have seen this before. Really cool thing, because it actually uses all the plugins, puts them all into one timeline. And we'll look into a few things, but the first things that I usually always like to use is PS3, right? This is just plain and simple. Show me the processes that are basically that Windows has been running, unless there's any hidden ones, but this is the plain and simple way of how to do it. And so you see by just piping or by just prompting this one, you can see this is kind of a tree-like structure of the processes that have been running. Now, again, I'm assuming people here are familiar with the process structure, with the basics, so I'm not explaining every single part of this, but given the information of this case, we've already come across a lot of details, right? We know that there's been a malicious file downloaded by Alice. Alice was logged onto the system. After that, we had a ton of PowerShell executions, malicious PowerShell agents that were connecting to our command and controls, to a command and control server. So what we'd be interested in is, is there any suspicious process, or is there any particular network connection that we could tie back to this particular case? So here we can see this is the typical process ancestry, where we have the processes that Windows uses to start up with in the top. And then if we go further down, we have a bunch of SVC host services. We can also see Splunk was running, more SVC host, Sysmon was running at the time when we took the image. And then from there on, we can see usually user activity starts somewhere around when we see Explorer. So Explorer basically here is when a user logs on, we have an Explorer process. And then below that, we can see mostly user-related processes. So we have Firefox. Firefox creates a ton of processes. Typically, we have a process called updated.exe. And then when we took the image, we, of course, can also see FTK imager.exe because that was the tool that we used to take the image with. So that's basically the simple, plain and simple process structure. Now the bad news is I kind of know, and I save you from wasting more time on this, but there is not anything that clearly sticks out. Of course, yes, we could look into Updata because that's a weird one, but actually not related to what we have been looking at. We have an update.exe.hda file, but not updata.exe. So we can ignore this one. And there's not really anything else there yet, even though we had PowerShell processes. Now, why might this be the case? So first of all, either those processes exited before we took the image, or they got paged out, as mentioned previously. I don't know. There's just no information about these processes that we would have expected in this particular process tree listing. So what else? We still know there might be files that were downloaded, and we could maybe extract file scan, or we could also do net scan and see if there's any network connections. Now, I think net scan actually shows something like this. So we could technically see, which processes have had which source and which local and which foreign address connected to. And really, if we are interested into the ones that are not listed on the local host, we actually just need to do netscan grab established, because those are the established connections. And now we have our system and the remote addresses, IP addresses that they had an established connection with. We can see 443 is the port. So this is typically a HTTPS connection. There's a connection that goes to 80 and so on. But if we remember from previous sessions, we had this user downloading something from Windows update.exe, which was an IP address that started with 3 something something, which is not on here. And we also won't be able to find it if we look closer or deeper. So just saying, this is the output, but we still don't have much information about this malicious one that we are looking for, which is unfortunate, but that's kind of how it works in real world environments. You don't always get to see everything that you expect, especially when it comes to the memory. Might have, again, maybe the process already had exited at this point. But that doesn't mean just because volatility can parse it out of objects that are currently in memory, that there isn't any data remnants or any evidence of this in there. So with that, we can look closer. We can perform a couple more things. Let me look at my cheat sheet here. So we also can do, for example, command line. And this is actually one of my favorite ones, because if we output the command line commands from with volatility, you can actually see a process that executed with the type of commands. And if we see too much Firefox, we might as well just do this one. And let's see if I've copied this now. And grep to not show Firefox. So this is number one forensics tool, right? Strings cat dump text, whatever, and grab it and leave out. So V means leave out the term Firefox. So now we don't have all this Firefox garbage in here. And we can actually see what executed on the system more clearly outside of just the Firefox thing. So there's the typical logon processes again that you typically expect. And then at some point, we have an Explorer. And this is where I would expect some of the Alice activity, right? Where we have command lines that should have captured some activity from Alice. And again, not seeing much here, but we do see FDK imager at the end. So clearly this did track some information, but malware-wise or compromise-wise, not seeing much, except this one is weird again, but not really part of this case. So not much we can go about. But again, another way of how to look into this. So what can we do? Let me go into a few advanced things now. Volatility is, since we know there was like no sophisticated process injection or shellcode or anything planted, doesn't really bring us information that we want to see, right? Processes, network connection, command lines. We can look more into logged on users, DLLs, registry stuff potentially, but or dumping files. Even in the files, I wasn't able to extract this particular file that I'm looking for. So a couple more things. I like the memes. Yeah, we have no leads yet still. What's going on? Well, let's change our techniques. We could also, and Volatility has a plugin also for strings, we could just extract all the text data that is in the unstructured memory dump and see if anything sticks. If we can find just evidence of something that we're looking for, right? Was this system compromised? Did it actually have a connection to a particular IP address? Did it actually run a particular command? Did it execute a process that might still be stored as a string somewhere, right? Not just even as part of Volatility and the objects that are in there. And for this, I have extracted all the strings from the system. Oh, this didn't do much, so let's do less. So here we have strings extracted by Volatility from the memory. Not a lot of useful stuff, but you can see we can read a few things. And that now, of course, requires some more advanced parsing. So one thing we are looking for is, let me copy some things here. I want to see, is there anything that PowerShell might have been doing? Anything, that was like relating to PowerShell that might be interesting to us. So what we really just need to do is we grab for the term PowerShell in strings and then look through the output. And so any string here per row is listed that actually includes something about PowerShell. And that already gives us something that we would have otherwise missed. This is, I don't know, a little suspicious, but then all of a sudden we have parent image PowerShell, parent command line, and then this kind of garbage, right? This is well, actually it's not garbage, payload, encoded payload that PowerShell was executing with no profile, no non-interactive window hidden, encoded as base64, this payload. And that's something that, if you have been in the previous sessions, is very familiar to us, right? This is how PowerShell or the attack actually execute an agent to establish command and control. Most likely. I've not translated this yet, but this is basically very suspicious. And this is now the payload that we could extract, right? And we would have missed it with Volatility, because this is some kind of command line that gets stuck in some kind of a tool that was apparently storing this as a string. And this string is still in the memory. So this is pretty awesome, right? We found a lead, and this lead is already something we couldn't have found with Volatility beforehand. Now, a few more things. Of course, this is not the only thing. We could look further. And then if I go further down, you see here, there's another one for those who have been here last time. We also should be familiar with this command, right? There's something current version /run. So this is the run registry key, creating a key called updater with the value execute PowerShell and take this particular payload that is being executed, is going to be executed from another registry location. So this is what we found before, right? Last time we saw there was a run key for persistence with payloads that were stored in different locations. So this is already another lead. We could look in there and see what happens. What is going to be executed? So from there, even more information, right? PowerShell with some more suspicious executions. We also had Atomic Red Team on there. So this is why we have a bunch of other PowerShell entries here, but that didn't do anything in terms of the case. So yeah, we could scroll further and further, but already this one was not too bad, I would say, right? Pretty interesting. Okay, so this was the PowerShell part. Now, would we be able to parse out any network indicators from this? Of course. Now, this can be more advanced. So I'm just copy pasting this here because we could apply regular expressions to extract anything that sounds like an IP address. So it looks like an IP address from the strings. And then we got this, right? There's regular expressions, and then there's the IP addresses that basically match an IP version 3. This one, if you remember, might be an interesting one that we are looking at. How many IP addresses did we get out of this? So basically you can do sort unique, I think, and then do a word count. So we got patterns. We got 1,200 like IP address, potentially IP addresses out of this memory strings dump. So that's pretty cool. If we just want to look at the unique ones, we do less, and now we have them all sorted. Of course, not everything here is an IP address, but we scroll a little further down, we can already get to, hey, there's a bunch of IPs, and this is evidence that at least we had something on there, right? And for our IP that we are looking for, somewhere in here, there's evidence that it shows up. So we have it. We've found it here. So that's another network indicator that's interesting, right? We can do even more so how many, get us some context around, why do these IPs show up? So they want to see a few lines before and after this IP address that actually might be interesting. So now I'm showing this IP address and show me 5 lines beforehand and 5 lines after this malicious IP address, or 3 lines, I think, 2 lines actually. So that this one actually is the context of why we are hitting on this IP address. So now I can see these entries, and these entries are surrounding this IP address. And based on my experience, that tells me this looks a lot like an entry from an event log, right? So we have, this is probably Sysmon network log, a network event created log or event. And this is capturing what connected to which destination. You can even see now this is an Amazon instance. And then there's more interesting information such as this IP address, and then there's these 5 entries. And we even have a URL now, right? The /admin/get.php associated with somehow associated with this IP and the port. So, and it's actually in the sysmon here. So we can already see there's also another sysmon entry, but now we extracted, even if we don't have the logs, some information about this context. Really cool stuff. And of course, we have many, many of these entries. So this is cool stuff with the strings, and to speed those things up, we can look for many patterns, right? We don't have to make up our own patterns all the time. And one way we can do so is by using a tool that is called bulk extractor. And bulk extractor is basically strings on steroids. Apologies for scrolling here. So this is going to be extracting all the patterns that strings can find on a unstructured file, such as a memory file. And if you do that, I've already done so. I've done so on the page file and on the memory file. Page file also includes interesting information, but for the sake of time, I'm just going to show you the memory real quick. This is what you get from bulk extractor. You get network patterns, you get event log patterns, you get IP addresses, you get email addresses, you get, let me see, is this sorted? Oh, actually, I should probably type it. So we get domains, a bunch of domains that were found. So this is the file size. We get email addresses that were found. We get URLs somewhere in here. We got URLs that were found. So this is what bulk extractor did for us. So we can do URLs. And then we can see, of course, a lot of those are garbage because they're just from random files. But if we are looking for a URL, and if we are just looking for, hey, was this system connecting to any interesting URLs? or confirmation of an URL that we are looking for, it might be in there, right? You can see a bunch of garbage, but also a bunch of interesting things that were just parsed out from random locations, such as files, right? There's a lot of XML header stuff, but also there's some YouTube and whatever. So here's the URLs. Same thing also for IPs, right? This is like doing things easier for us, making things easier for us, actually telling us what kind of IP address more clean, right? I already saw the one that we are looking for. And same thing for emails, right? If somebody opened an email from the recipient, or actually the sender might still be in here too, right? Email patterns parsed out here as well. So highly recommend this kind of tool as well. Not everything is always as easy to find with volatility. So understanding how to parse through the unstructured data is important as well.